welcome to Lesson 12 of Module 4. In the last two lessons, we have been creating linear equations in two variables by looking at some proportional relationships like constant speed and different constant rate problems. And we did begin to graph those. So we're going to continue in that along that line. These will be different types of linear equations in two variables. And so you'll just get to see some more examples of that because there are lots of them. Okay, so for this lesson, even for the classwork, you will need some extra graph paper. The tables and the questions are in your classwork, but no graph paper. So make sure you have some graph paper as you get started here. And okay, and so let's go. So this opening exercise asks you to come up with some combinations of ways that Emily scored points in a basketball game. So she tells you that she scored 32 points in the basketball game, and she with only 2 and 3 point baskets, no free throws, so no 1-pointers. How many of each type of basket did she score? And we're going to use this table to organize the work. So I want you to pause the video and work on that. I'll do one example just to get you started so you see what we're talking about here. So if she didn't score any 3-pointers, we could say all of her points were from the 2-pointers, so she made 16 shots of those. So 16 times 2 is 32, plus 0 is 32. Okay, so see if you can find 5 more combinations like that work. Okay, so maybe you discovered that she would have to do an even number of 3-pointers. She couldn't do one 3-pointer because that would be an odd number, and the 2-pointers are always going to be even, so she'd never get the 32 points. So we won't do that. So I'm going to give her 2 3-pointers, and if she did that, that would account for 6. So that would leave 6 points that she didn't need to score with 2-pointers. So she would have only needed to score, let's see, 26 points with 2-pointers, so that would be 13. Okay, and so if you continue with that line of reasoning, whoops, she can't score 3 of those. If she scores 4 3-pointers, she could score 10 2-pointers because 10 times 2 is 20, 4 times 3 is 12. Those add up to 32. 6 3-pointers and 7 2-pointers, so it'd be 14 points over here and 18 points over here. It also adds up to 32. And 8 3-pointers and 4 2-pointers, pretty unlikely, but it could happen. 4 times 2 is 8, so that's 24 plus 8 is 32. And then we could have 10 3-pointers and 1 2-pointer. So that would be 2 and 30. Okay, so hopefully you didn't just watch me do that, you worked with it. So now we're going to write a different type of linear equation in two variables. They're telling us let x be the number of 2-pointers and y be the number of 3-pointers. So our variables are defined. We have x and y that she scored. Write an equation to represent the situation. So work on that for a minute, pause the video, and then come back and check your work. All right, so when with the number of 2-pointers, let's take a row like this as an example. So the number of 2-pointers was 10, but we're using x for that. In order to figure out the points that she scored with those 2-pointers, we had to multiply it by 2. So we had 2 times the number of 2-pointers, and then we would have to add that to 3 times the number of 3-pointers. Over here we had 4 for that this time. 3 times 4 was 12, but this would be 3 times y. We add those together, and we want that to equal 32. Okay, so that is another example of a linear equation in 2 variables. And we're going to be working with this form today. It even has a special name, so let's talk about that for a minute. So we're going to say that when an equation is of the form a, some number a times the variable x plus some number b times the variable y is equal to c, that is a special type of form called standard form. So you can put that in your notes somewhere. This is standard form of a linear equation. Okay, ax plus by equals c. I'm going to do something here. Let's find a color that will show up. I'm going to, this a, b, and c, let's put it in a different colors. Will that show up? A, b, and c. Because the a, b, and c are really different from the x and y. The x and y are variables, and the a, b, and c are constants. They're numbers. So in our example, 2x plus 3y equals 32. C is 32, b is 3, and a is 2. And our variables are just that. They're variables who we want to be able to put in any number for that, for a given equation. So this is called standard form. Any linear equation can be put into this form. And so things could be rearranged, but the standard form is useful for comparing linear equations. Okay, so one thing we found with the basketball shots equation here is that not every x and y are going to work. Only certain ones will. And when we find two numbers x and y that work, we could write them as an ordered pair, like that. And you've seen this before, most of you. And so one of the ordered pairs that worked for this was if we let x be 10 2-pointers, then she scored 20 points that way, and then she scored 4 3-pointers. So 10 4 was a solution to that equation. So they're written in the form xy as pairs, as ordered pairs. Okay, so let's look at a different linear equation here. So consider this linear equation here. So in this case, we have A is negative 50, C is 15, but what is B? Yeah, B is 1, but we don't have to write it because the coefficient 1 doesn't change anything when we're evaluating it, so we don't need it. So, but B is 1. So here's an equation. So seems pretty apparent that not every x and y is going to work. So we could, we could check one. We could check an xy pair. Let's check 1, 2. So this would be x equals 1, y equals 2. So if I put that into my equation, I get negative 50 times 1 plus 2, and I'm asking myself, does that equal the right side of the equation of 15? And it doesn't, because this would be negative 50 plus 2, and this would be negative 48. So that is not equal to 15, the left side. So there would not be a solution to the equation. So in this lesson, we're going to look at some efficient ways for finding solutions to equations in standard form. So one strategy would just be to start to guess numbers and to find a pair that makes the equation true. That can take a long time in situations like this. So one thing that we can do is to just pick a value for one variable and then solve for the other one. So for instance, if I say I'm going to let x equal, let's let x equal 5, and then find out what y is. So if x is 5, I would have negative 50 times 5 plus y is equal to 15. So this is negative 250 plus y. And now if I add, let's show it, if I add 250 to both sides of this equation, then I end up with y equals 265. So if x is 5, y is 265. Okay, so there's one ordered pair that works. So there's one solution. Let's write it up here. So we'll have 5 and 265. Okay. Okay, but if I can do it for x, I can do it for y. So what if I let y be something? Let's let y be 5. In this case, let's let y be 5. And so y equals 5, and this time I don't know what x is going to end up being. So if y is 5, then my equation looks like this. I'll have negative 50 x, because I don't know what x is, plus 5 is 15. So to solve this equation, I'm going to need to subtract 5 from both sides. My new equation would be negative 50x is equal to 10. And I'm going to need to divide by negative 50 to get x by itself. And so then I'm left with x equals negative 10 over 50, and simplifying that, I get x equals negative 1/5. Okay. Negative 1/5 right there. So there's another ordered pair that works. And so that ordered pair would look like this. In this case, x is negative 1/5 and y is 5. Okay? So before we move on to the next section here in your classwork, why don't you try to find another pair, another xy pair that would work in this equation. So you could choose something for x and solve for y, and then you could choose something for y and solve for x. This would be really great if we were in the classroom. We could look at each other's solutions. And you kind of want to convince yourself that whatever number you choose for either of those, you could find a pair. So there really is an infinite number of solutions to an equation like this. Okay, so now let's work on the exploratory challenge number 1. You're asked to find 5 solutions for the linear equation x plus y equals 3. And then plot the solutions as points on a coordinate plane. So we'll do that too. But I want to point out that these equations are still written in ax plus by equals c. Okay, in this case right here of x plus y equals 3, a is 1, b is 1, and c is 3. Okay, so go ahead and pause the video and find 5 solutions to this. You can find more if you want, but find at least 5 to fill in the table. And then we will do a graph together. So you will need your own graph paper for this. So make sure you have that. Okay, so I'm going to start with a simple one. If I let x be 1, then I would have the equation 1 plus y equals 3. And I can see that y would be 2. Okay, if I let x equal 2, I would have the equation 2 plus y equals 3, and y would be 1. I could choose, you may have done this differently, but I can just keep choosing like that. So if x is 3, then I have 3 plus y equals 3, so y has to be 0. If I have the equation 4 plus y equals 3, you might need to realize, if you can't see exactly what that would be, subtract 4 from both sides, and you end up with -1 for y. And then using 5 plus y equals 3, y would equal -2. So here's our ordered pairs, 1, 2, 2, 1. So we're going to go ahead and graph these now in the coordinate plane. Okay, so here's a blank coordinate plane. I'm going to use a scale of 1 for each square. So when you do this, you don't have to number every one. I like to number like maybe up to 5. 2, 3, 4, 5. So there's 5, and then also on the vertical axis. 4, 5. Because you can have a different scale on the horizontal axis and the vertical axis. It just has to be consistent across any one scale. I didn't mean to do that. So I could have it going by 1s here and by 2s or 5s or 10s here. As long as I'm consistent, that will work and give us a graph that makes sense. Okay, so if I want to put the negatives on here too, I could. So 1, 2, 3, 4, -5, -5. Okay, so now whoever's looking at my graph knows that each of those squares stands for 1. So I'm going to plot these solutions. So when x was 1, y was 2. There was 1. And then I had x being 2 and y being 1. And then when x was 3, y was 0. When x was 4, y was negative 1. And when x was 5, y was negative 2. All right, so those are the points, and you might have had others. Let's think of another one that might have gone on this graph. If x, let's see what will fit. If x is 7, then y would be negative 4, right? So let's find that point. 6, 7, 1, 2, 3, negative 4. So, and if we picked, what if we picked y equal to 3? If y is equal to 3, then x would have to be equal to 0 so that they'd add up to 3. So we have another point here. So, and you may have had more right there. So these all fit the equation x plus y equals 3. Okay. Okay, so now look at exercise 2. We have this linear equation 2x minus y equals 10, and we're going to find some solutions to it. So we want to pick values for one of the variables and then solve for the other one. So let's go ahead and do what we did before. We'll pick 1, 2, 3, 4, and 5 for x, and we'll put those in and solve for y. And so this linear equation would then be 2 times 1 minus y equals 10. So that's 2, just save room here, 2 minus y equals 10. So if I subtract 2 from each side, I get negative y. Negative y is equal to 8. And if negative y is equal to 8, then y, y is equal to negative 8. Okay, and I could think of that as multiplying both sides by negative 1, which I can do, the property of equality for multiplication. Right there, multiply each side by negative 1, I get y is negative 8. All right, so there's one solution. So find some others. Pause the video, find the others, and then come back and check your answers against these. Okay, so my data table shows the x, y values for these that we chose. You can kind of see a pattern, can't you? As the x's go up by 1, the y values are going up by 2. They're getting bigger from negative 8 up to 0. So let's go ahead and plot those points in a coordinate plane. Okay, so here's the same coordinate plane. I'm going to use the same scale of 1 for each grid line on this scale as well. So we had these data points. We had 1, negative 8. We had 2, negative 6. Okay, those are our points, and this equation is 2x minus y equals 10. Okay, so when x was 1, y was negative 8. And that would be right down here on the graph. When x was 2, y was negative 6. Oh, yeah, that's right. When x is 3, we had negative 4. Get that on there. And when x is 4, negative 2. And then we had the point x equals 5, y equals 0 right there. So those were the 5 values that we had for x and y. What if we put, we could have chosen a value for y. What if we wanted to know when y equals 0? For y equals 0, well, we could plug in and we'd get 2x minus 0 equals 10. So 2x would equal 10, so x would be 5. Sorry, that was the point we already had. I forgot. I was thinking when x is 0, but what about, let's do a different one for 5. What about when y is something bigger? Let's pick something else for y. I want to know what happens to the graph when I get further up the y-axis up here, up in here somewhere. So let's pick like y equals 5 and see what x is. So if y is 5, whoops. If y is 5, then this equation becomes 2x minus 5 equals 10. And if I add 5 to both sides, I get 2x is equal to 15. And x is equal to 15 over 2, which is 7.5, right? So I'm going to find that y equals 5, x equals 5, 6, 7.5, and that point would be right there. A little bit high, but right about there. Okay, so there's not going to be just one answer. You could have picked different values and had different points on the plane, but they should fall in. Maybe there's some overlap to this one. Okay, let's look at another example. Okay, for exercise 3, if you haven't started it yet, I'm going to make a suggestion, and that's that you might want to pick points for y instead of x. And the reason for that is if you pick points for x, you're going to end up with some crazy fractions that you're going to be plotting. So since we want to plot these, not that there's anything wrong with fractions, but they're just a little harder to plot on the coordinate plane. So I'm going to pick, on this one, I'm going to pick some values for y instead of picking values for x. So if y is 1, then I end up with x plus 5 times 1 is equal to 21. Subtract 5 from both sides, and I get that x is equal to 16. Okay, and so on for these. So if y is 2, then I get x plus 5 times 2 is 21. Subtract that 10 from both sides, and I'm going to get x is equal to 11. See how much easier this is? We'll try one with picking an x, and if you can't see how much harder that would be. So this would be x equals 1, and then if x is 5, we'll have x, or I mean if y is 5, x plus 5 times 5, which is 25, is equal to 21. And if we subtract, I'll write this one out, subtract 25 from both sides, we're going to end up with x equals 21 minus 25 would be negative 4. Okay, so those are our ordered pairs that we're going to plot on the coordinate grid. Had we chosen something for x, let's say if we chose x equals 1, then we would have 1 plus 5y equals 21. And then, oh, that one's going to work out. Then we would have 5y equals 20 and y equals 4. But let's do a different one. If we had x equals 2, so that's another good ordered pair right there. I don't think we did have that one. We had it right here. Never mind. If x is 2, then we would have 2 plus 5y equals 21. Subtract 2 from both sides would give us 5y equals 19. And then dividing by 5, we would get y is equal to 19/5, which is fine, but it's just harder to plot, right? So, so just depending on the equation that you're given, sometimes one strategy is better than another. Okay, so let's look at the graph for this equation. And we'll go ahead and use, I think we can use our one and one thing again. 2, 3, 4, 5. 1, 2, 3, 4, positive 5. The nice thing about having graphs that aren't numbered already is that you can create your own scale. Okay, let me jot down the points that we'll be plotting here. Okay, so I'm going to start plotting these points, and I'm going to start from the bottom and go up. So we'll do this one first. So if x is negative 4, y is 5. Negative 4, 5. So those of you who are still struggling, I went over here to negative 4 and up to 5. Okay, I'm going to continue plotting these points. Okay, so they're all plotted here. So when x was 1, y was 4. When x was 6, y was 3. When x was 11, y was 2. And for x is 16, y is 1. I had to extend my graph out a little bit, but it still works. You might be noticing a pattern to the points that we're graphing in these linear equations, that they tend to look like they're all in a line. And they do look like that, and we're going to get to that. So no need to connect them at this point, but just I hope that you're recognizing that. All right. All right, let's look at exercise 4. We're considering the linear equation 2/5 x plus y equals 11. And there's two questions here. Will you choose to fix values for x or y, or both, and then explain? And then B, are there specific numbers that would make your computational work easier? Okay, so think about that. Try out some things and see what makes it easier. and then come back and we'll talk about it some more. Okay, so hopefully you noticed that because y has a coefficient of 1, that picking values for x is easier. So I would pick values for x, because then it's only one step to solve for y. And that's because, once again, this coefficient of the y is 1. And not only that, in part B, if I pick, I want that fraction to go away. So if I pick multiples of 5 for x, then when I multiply by 2/5, 2/5 times a multiple of 5, like 15, then I eliminate the denominator, or the the denominator, and my numbers become much easier. So I'm going to pick multiples of 5 for x to make this simpler. I could do something else, of course, but it makes my life more difficult. So let's pick some multiples of 5 for x. We could actually pick 0 for x as well. So that would be a good place to start. But then we could pick some other multiples of 5. So we could do 5, 10, 15, and 20. So if x is 0, then I have 2/5 times 0 plus y equals 11. So y would be 11. And so on. So go ahead and do the rest of those. Come back and check your work. Okay, so check your solutions here against mine to make sure you're on the right track, and then we will go ahead and graph these on a coordinate plane. Okay, so I've recorded the points that we're going to be plotting. Here's our equation. 2/5 x plus y equals 11. And I chose to make every grid point equal to 2 in order to fit the points on the scale that we're using. So let's plot the first point when x is 0, y is 11. So that would be about right there, 0, 11. When x is 5, now we're going to have to go in between the grid points to get these. So when x is 5, y is 9, about right there. I'm going to plot the rest of those while you do it, and then you can come back and check your work. So pause the video now. Okay, so on my graph, again, I had 0 and 11. I had the point 5, so this is 2, 4, and then 5 is between 4 and 6 here. 5, 9, and then I had 10, 7, 15, 5, and 23. So if you had more room on your graph paper, you could have done each grid point equaling 1. That would be a little easier, but you can do this. So once again, we're noticing that these points certainly look like they're in a straight line. Okay, but we don't know that for sure yet. We're going to address that in the next lesson. Okay, so let's look at example or exercise 5, and then we'll be ready for the exit ticket. Okay, in exercise 5, we're going to be writing an equation again, kind of like our opening exercise with the basketball example. So at the store you see you can buy a bag of candy for $2 and a drink for $1. Assume you have a total of $35 to spend. You're feeling generous and want to buy some snacks for you and your friends. Of course, you wouldn't eat all of that, right? So we're going to write an equation in standard form to represent the number of bags of candy and the number of drinks that you can buy with $35. Okay, and so some variables have been defined for us. So X is the number of bags of candy, and Y is the number of drinks. And the total we can spend is $35. Okay, so you can work on this. Work on this on your own and see what you come up with, and then I'll kind of talk you through it if you have trouble here. So go ahead and pause the video now, work on that, and then come back and see what the solution should be. Okay, when I do a problem like this, I like to think in terms of like a verbal model first. So I'm going to use words. And so I'm going to say that the dollars spent on candy plus the amount I spend on drinks would be my total spent. Okay, so I haven't put in any numbers yet for the equation, but I kind of have this idea going on. So I have to figure out what's the total I spend on candy, total I spend on drinks, and that will equal my total spend. So my total spent, I know, is $35. So I just have to figure out how much am I going to spend on candy. Can I write an expression for that? So the amount I spend on candy is going to depend on X, right? Because that's the number of bags of candy. If you look over here, number of bags of candy is X, and I'm going to spend $2 for every bag of candy, so that's going to be 2 times X. And then an expression for drinks, the number of drinks is Y. I'm spending $1 on each drink, so it's going to be plus 1 times Y. So this equation becomes 2x plus, I can leave the 1 off, 2x plus y is equal to 35. And all the XY combinations that fit that will tell me how the number of bags of candy and drinks that I can buy for $35. Okay, so let's create a table for that equation. So my equation is 2x plus y is equal to 35. So I'm going to use the same methods that I've used before by picking values for x and y that that give me solutions, and then we'll plot those on the coordinate plane. Okay, so play around with that and then come back and check and see what points I did. They might not be the same as yours, but you can check to verify that they're correct. Okay, so I am going to start with 5 for x, 5 bags of candy, so 2 times 5 plus y equals 35. 2 times 5 is 10, so if I subtract 10 from both sides, I'm going to get y equals 25. So if I buy 5 bags of candy, I can get 25 drinks. Okay, so that's kind of out of balance. So maybe I'll get more candy. So let's let x equal 10. So 2 times 10 plus y is 35. 2 times 10 is 20. Subtract 20 from both sides. I get y is 15. Okay, I'll do a couple more. Okay, so you can check your work against these data points that I've calculated. And so once you do that, we're going to now make a graph of this equation. So our equation is 2x plus plus y is equal to 35. And some of the points that we'll be graphing are okay, I've set up my graph a little bit differently. I don't need all 4 quadrants of the coordinate grid because for this problem, it really only makes sense to have positive numbers. So, and they're a little bit bigger. So I went with a scale of 2, 2 for each grid line. And so this is what it would look like. So let's start plotting points. So we have, I need to label the axes. So I have X and Y. So remember, X was the number of drinks and X is the bags of candy and Y is the number of drinks. And so when I had 2 bags of candy, I could get 31 drinks. So that would be right about there. 31 drinks. So 2, 31. Then I have 5 and 25. So I'm going to follow that up. About right there. 225. Or 525 rather. And then when X was 8, Y was 19. About right there. And then 10 and 15. 2, 4, okay. And then 15 and 5. So 15 and 5 is about right there. Okay, so this plots some of the combinations of drinks and candy that could be bought for $35 total. All right, and they're all positive. Now, could have picked negative numbers, but they wouldn't have a meaning in this situation, right? So we're going to stick to positive numbers for this one. Okay. So let's summarize what we've done in this lesson. We saw that a linear equation in 2 variables, when it's written in this form of ax plus by equals c, is called standard form. So it's going to be standard form of a linear equation in 2 variables. And a solution to a linear equation in 2 variables is an ordered pair that makes the equation true. So a value for x that goes with a value for y that makes the equation true. And we found solutions by fixing a number for x and solving for y, or by fixing a number for y and solving for x. Okay, so you are ready to do the exit ticket and problem set for this lesson. You will need graph paper in order to complete these lessons. Okay, good luck, and we'll see you back here for lesson 13.